Have you ever wondered why atomic particles don't act like the big particles that we see every day? It's because of the quantum mechanics. It's a scientific theory that challenges what we know about the universe, especially when things get extremely small. In this micro world, the normal rules of how things work don't apply. It's a place where what seems impossible becomes possible, and what's usually definite becomes uncertain. Even though quantum mechanics might seem far from our daily lives, it actually affects more than you might think. Before we unveil the quantum mechanics, make sure to subscribe to our channel and press the bell icon to get regular updates. Let's explore this quantum world together. Understanding quantum superposition. As you learn more about quantum physics, you'll find out about an interesting phenomenon called superposition. In everyday life, flipping a coin is a simple and easy to understand example. It's clear whether the result will be heads or tails as the coin falls. But as we learn more about quantum physics, we see a big difference between how macroscopic things behave and how their quantum cousins behave. Quantum particles are strange because they can be in more than one state at the same time, while ordinary things always behave in predictable ways. The proper name for this state of being in more than one state at the same time is superposition. To understand this idea, think of a coin smoothly spinning through the air, refusing to show either heads or tails, as is usually the case. The fact that quantum particles can exist in more than one state is what sets them apart from the physical rules that govern our everyday lives, which are predictable and fixed. The role of measurement in quantum reality. If we look into the part of measurement, we can see how complicated quantum mechanics is already. When you measure something in quantum physics, it changes things in ways that are not possible when you just watch a coin spin and catch it at the right time. A quantum particle lives in a mixture of states before it is measured. A wave function beautifully shows this. But the most important moment comes when the choice is made to look closely at its state. The wave function breaks down, and the quantum particle takes on one of its possible states for sure, either heads or tails. In this quantum world, results are unknown until the conscious act of measurement is carried out. Our usual ideas about certainty and fate are called into question by this, since the observer's action changes the very nature of a quantum particle's state. The dance between superposition and measurement shows us a strange world where reality itself seems to change based on the choices we make as we try to figure it out. The mysteries of quantum entanglement. Have you ever thought about the strange way that two particles can quickly affect each other, even if they are very far apart? Enter the confusing world of quantum entanglement, an idea that pushes the limits of what we know about the complicated framework of quantum physics. This mysterious dance of the quantum world creates an interesting link between particles, where their properties mix and become one, defying the usual rules of space and time. To better understand this effect, imagine a big stage with two dancers moving in perfect sync with each other. It doesn't matter if they are in different corners. Their moves are always perfectly timed. Now move this story into the world of quantum mechanics, where tiny particles like electrons are the stars. Once two electrons get entangled, their spin states are linked in a way that looks like dance steps. Interestingly, reading the spin of one electron instantly reveals the spin of its entangled partner, even if they are separated by light years. The cosmic dance of entangled particles. Quantum entanglement adds a mysterious dimension to our knowledge of the world. It suggests a way for particles that are entangled to talk to each other that doesn't follow the usual rules of the speed of light. The established rules of physics are called into question by this idea. This makes us rethink the basic ideas that help us understand the world. It is important to note, though, that quantum entanglement does not allow for telepathy or normal communication. It may make it seem like particles are sharing information faster than light, but it does not. Quantum entanglement doesn't make it easier to communicate quickly. Instead, it creates a perfectly timed link between particles, like a very carefully planned cosmic dance that starts when entanglement happens. Surprisingly, this mysterious dance goes beyond our preconceived ideas of what is possible, pushing the limits of what we think is physically possible. Since there isn't a clear thread linking these particles, the mystery grows, adding another level of interest to the already fascinating field of quantum mechanics. Quantum mechanics in everyday technology. There are a lot of people who consider quantum mechanics to be a theoretical concept in the field of physics, but is actually closely tied to a lot of instruments that we use on a daily basis. When it comes to the ways in which it has impacted so many aspects of life, modern technology is a compelling example. Consider transistors, which are the components that power computers and mobile devices. The principles of quantum mechanics are the basis for their operation. Tunneling is a quantum process that allows particles such as electrons to pass through walls that classical physics had previously stated were impossible to pass through. These very small switches make use of this quantum phenomena. The lessons that we can learn from quantum physics extend far beyond the realm of electronics. In spite of the fact that they are still in the first stages of research, quantum computers have a great deal of potential. Through the utilization of concepts such as superposition and entanglement, these future computers have the potential to surpass even the most powerful supercomputers in terms of their level of power. Because of this, it is now feasible to solve difficult problems at speeds that were previously thought to be practically impossible. Furthermore, the advancements that have been accomplished in quantum mechanics are not exclusive to the realm of technology. Rather, they have significant implications for a wide variety of other scientific domains as well. These quantum jumps have the potential to modify a variety of sectors, including the study of materials and the field of medicine. Quantum physics, for instance, has the potential to result in the discovery of novel and significant discoveries in the field of medication development. The capability of simulating molecular interactions at a level of complexity that has never been observed before could lead to the development of novel methods for the production of medications and the acquisition of knowledge regarding the functioning of biological systems. Wrapping up the quantum world. When we dive into the complicated world of quantum physics, we find ourselves in a mind-boggling setting that makes us question what we think we know about reality. The idea of superposition is at the center, which shows an interesting process in which particles can be in more than one state at the same time. This quirk of quantum mechanics takes us to a world where everything seems to go against what we normally think is true. It's only as we learn more about the quantum world that we can figure out what entanglement is all about. Einstein, who had a very smart mind, called it spooky action at a distance. This strange link between particles goes beyond the limits of space and opens up a world of options that are hard for us to understand. These quantum quirks have effects that go beyond labs and theoretical talks. They change the way we live our daily lives. The technology in our pockets and the stars in the night sky are both affected by quantum events. These effects are everywhere and are woven into the fabric of our lives. As we go deeper into the quantum unknown, we can only think about the secrets that lie ahead. Even though the quantum world is strange by nature, it also holds the promise of discoveries and exciting adventures. We are amazed by how unpredictable quantum physics is, which makes us want to question and study what we think we know. If you've enjoyed this exploration, show your support by liking, sharing, and subscribing to our YouTube channel. Your support fuels our growth, allowing us to bring you more captivating content as we collectively navigate the wonders of the quantum world. Thanks for watching.